length of time a person has lived. Twins. Two children born at the same birth, at the same time. But what if the age of twins was different? How would this be possible? The twin paradox scenario involves a pair of twins. One is an astronaut traveling into space, and the other is staying on Earth. Once twin A arrives home after the many years of space exploration, it appears that twin B, and everyone else on Earth, has aged more than twin A. But how is this possible? For this peculiar case to be explained, we must turn to the genius of Mr. Albert Einstein. But do not let that scare you. In 1905, Einstein proposed the idea of special relativity. The main rules that we need to understand are: 1. The speed of light is constant for every observer, regardless of motion. That speed is 300,000 kilometers per second. And 2. The laws of physics apply to everyone in inertia. This just means anybody that is either stationary or traveling at a constant speed. This means that in a car traveling at a steady 50 miles per hour, you can throw a ball upwards and it will experience no horizontal movement relative to us in the car. We can only tell that we are in motion because we see things moving past our window. If I were to tell you that it is possible to go slower by moving faster, you might call me insane. But following the rules of special relativity, it must be true that at higher speeds time appears to slow down to passers-by. Continuing with the car example, if you are sat inside and throw the ball half a meter in the air, it will go up half a meter then fall half a meter, overall traveling a distance of 1 meter. But to a pedestrian outside, the ball hasn't gone straight up and down, but has traveled at a diagonal on a much longer path due to the additional motion of the car. This is an analogy for the light clock, with the ball representing light. But if light travels at a constant speed no matter what and the distance traveled is longer from the observer's perspective, then it must have taken a longer time to complete a 1-second cycle. Thus the moving light clock, or car, experiences time at a slower rate than the pedestrian. This is known as time dilation. Applying time dilation to the original scenario, the twin in space is traveling at a high speed, let's say 99% of the speed of light. Using this equation we can calculate the experienced time difference. In this instance, t0 is the time passed in the observer's own frame of reference, v is the speed of the moving object, and c is the speed of light, at 300,000 kilometers per second. If the astronaut twin ages 10 years during his time in space at this speed, we can see that everyone on Earth will have aged by about 71 years. Hold on a second. If motion is relative, how come space twin aged slower than Earth twin and not the other way around? From space it appears that Earth is moving away, and you are stationary. So how can we be sure? It turns out that this isn't a symmetrical case. When the space twin turns around to come back to Earth, they accelerate so are no longer inertial. This means that special relativity no longer applies to them. You could argue that the Earth accelerates at this point from a spaceship's perspective. But only the spaceship is actually accelerating, so it cannot be argued this way. So, the twin paradox is very much real and possible. It just seems like a paradox. But once you're up to speed with special relativity, it's easy.